Alright folks, hello and welcome to this video example on section 8.5 continued. We're looking at the subject of complex fractions. As always, I recommend that you copy down these definitions and examples into your notes so you have them for future reference. So let's tackle these complex fractions, which are part of a broader unit on rational functions and expressions. A complex fraction is a fraction that contains another fraction in its numerator and denominator. Okay, just fix the typo there with contains. So that means somewhere in the fraction, let's just say we have a fraction bar. Well, we have fractions inside of fractions. So perhaps we have something like this. 1 over x plus 2 over x plus 1. And in the denominator we have y plus 2 over 3. Here we have three separate fractions all inside of fractions. So we would call this entire thing a complex fraction. Our goal is going to be to simplify these things. In fact, if you have a final answer with a complex fraction, it is never considered simplified. And that goes for any level of mathematics. Okay, so never allowed in your final answer. Okay, you're never allowed to have a complex fraction in your final answer if it's to be considered simplified. So we have two methods for simplifying, and we'll look at these in action in an example in a moment. Method 1 is going to be to obtain a single fraction in the numerators and denominator, and then divide the fractions. Okay, just fixed another typo there. Obtain a single fraction in the numerator and denominator, and then divide the fraction. So you're going to work in this one above. We would have to get these to be one fraction. This one here is already one fraction. So once we have a fraction divided by a fraction, we can use the familiar method of dividing fractions, which is going to be to multiply by the reciprocal. That's method 1. Method 2 is going to be to skip that step of getting a single fraction and just go right ahead, right away, multiply the numerator and denominator by the LCD of every fraction in the numerator and denominator. So you're going to have to find the least common denominator of every single fraction. And if you multiply both the numerator and denominator by that, all the denominators are going to be divided out, and you're going to have something that you can simplify. Okay, so we'll look at that method in a moment as well. So without further ado, let's proceed to some examples. Alright, so let's take a look at this first example. Notice in the numerator we have fraction 5 over x plus 4, and in the denominator we have two fractions, 1 over x plus 4 and 2 over x. So for this example, we're going to follow method 1. And for method 1, it says that we want to get a single fraction in both the numerator and denominator. Notice that the numerator already has a single fraction, and the denominator has two fractions. So therefore, we want to be able to combine those two fractions in the denominator to get a new denominator that's just one fraction. So I'm going to take these and make them a separate problem. And we're going to do 1 over x plus 4 plus 2 over x. And we want to make a common denominator and add these together. The common denominator is going to be x times x plus 4. So that the denominator on the left, I attached an x to that product, so I'll attach an x in the numerator. And the denominator on the right, I attached an x plus 4 in that denominator, so I'll attach an x plus 4 in that numerator. We then simplify. This will be x plus, distributing, we get 2x plus 8 over x times x plus 4. Which gives us the single fraction we desire, 3x plus 8 over x times x plus 4. Now let's think back to our problem here. We have 5 over x plus 4. That was the original numerator. Draw an arrow down here. Division sign, because we're dividing by this thing here is a big fraction bar. We're dividing by that whole thing. Okay, in this type of problem, Phil is screaming, divide. And so we're dividing by our new fraction there, 3x plus 8 over x times x plus 4. And in the familiar way, when you divide two fractions, you have to multiply by the reciprocal. That's the rule that we employ from basic arithmetic. And so the reciprocal will be x times x plus 4 over 3x plus 8. And then we divide these factors to 1, since they are the same factor, leaving us with a final result of 5x over 3x plus 8. And that is an example of how to simplify a complex fraction. In the next example, we'll look at method 2. So here we have a complex fraction, though it's kind of concealed by these negative exponents. So let's rewrite this using our knowledge of negative exponents. This will be 1 over a squared minus b squared over 1 over a minus b. And in this example, we're going to use method 2, which doesn't mean find a single fraction in the numerator or denominator. That's method 1. This means we want to multiply numerator and denominator by a common denominator of all fractions in the problem. Or in other words, I'm going to multiply the numerator by a squared and the denominator by a squared. So why am I doing this? Well, notice these b's are just simply over 1 if we wrote them as a fraction. So we have two fractions here. We have an a squared in the denominator, or two denominators, and we have an a in the denominator. So the common denominator is simply a squared, because that accounts for every single factor of every denominator. And it's legal to multiply by a squared over a squared, since it's a form of 1. We could divide those out again, a squared divided by a squared, and just get 1. So now to multiply these, we've got to be careful to distribute to each part of the numerator and denominator. When we do that, a squared times this just becomes 1. A squared times this becomes minus a squared b squared. Okay, I just put the a first because it's alphabetical. Big division bar. In the denominator, we distribute, and we get, let's see, a squared over a will just give us a, and then a squared times b is minus a squared b. Okay, so that looks pretty good so far. Now we just have a regular rational expression. It's no longer a complex fraction. So we should see if there's any factoring possible before declaring ourselves done. In the numerator, we actually have a difference of squares. We can make that 1 plus ab and 1 minus ab. And in the denominator, we can factor out an a to create 1 minus ab. Then, dividing common factors, we arrive at a final simplified answer of 1 plus ab over a. And that's an example of how to simplify complex fraction with method 2. Okay, both methods will work on both problems. So if you want to go back and try one of these examples or your homework examples with a different method, that's perfectly fine. I would practice with both and find which one is best for you. Heading to our final slide, we now have a brief summary. Just what we did in this video, we first defined complex fractions as fractions inside of fractions. We explained two methods that you can use, method 1 and method 2, to simplify complex fractions. And lastly, we looked at two examples of how that simplification process works. Use this to help you with your homework, and thank you for watching this video lesson.